Welcome back to our lectures on classes and object relation mapping. We're going to continue building out our example of kind of operating a human resources program at a company. And we're taking the kind of object-oriented approach at the moment, defining all of our Python classes that will serve to represent employees in the company, as well as project groups. So in the previous lecture, we defined a person object. But at our company, people have roles. Some, people at the company are generally employees, and some of those employees are managers. So we're going to define some classes that inherit from that person class we defined earlier and expand upon or alter the functionality of the person class to add specific attributes and methods that are relevant for employees of a company. So employees at a company, in addition to having all the properties a person might have some additional properties. They might have an employee ID and amount of work they can produce in some unit time. So our employee is going to be initialized giving all the arguments we had for person, name, age, degree, and salary, but also an employee ID and a production level. And the first thing we do when we initialize a person object is first to essentially initialize when we initialize an employee object, the first thing we do is to essentially initialize a person object. So this super employee self is essentially the same as if we had said person. It's a little bit more general because we don't need to explicitly refer to the person class. We just refer to the superclass of employee. Employee inherits from person, so person is the superclass of employee. Then, after we've initialized a person object, we initialize the ID and production of our employee. We also define a repr method, which will represent our employee as a string. We then define a manager class, which inherits from employee, because managers are special types of employees. They are a specific type of employee. So manager is a subclass of employee, because managers should have everything an employee has, plus some extra attributes and methods. So again, the first thing we do when we initialize a manager is to initialize an employee. Just like the first thing that happened when we initialized an employee was we initialized a person. And then additionally, a manager is going to have a capacity, an amount of employees that manager is capable of managing. And as a complement to that idea, we have a method called canManage, which checks if a manager can manage n employees. And this is a very simple method. It just checks if n is less than or equal to that manager's capacity. So this will return a true or false based on n. If I define a manager with a capacity of, say, 5, an ID of 281, production of 58,200, name is, let's say, Blair, they're 35 years old, and, oh right, we need to give them a degree and a salary. So I'll just copy those from our previous example, just for the sake of speed. So here's our manager. And if we ask if they can manage 6 people, well, 6 is greater than their capacity, which is 5, so we get false. But they can manage 5 people, so we would get true. So at this point, we have all the classes we need for describing the individuals in our company. Our company has employees. Some of those employees are managers. And that will give us like a very basic structure for the company. But we're going to introduce some additional objects to illustrate the organization of the company. So it's commonplace for managers and employees to be grouped up into teams. And teams might work on specific projects or handle specific lines of business, or have particular responsibilities that are complementary to each other. So we're going to define a team, but first, just like we defined a person, which was a sort of general base class for that we would inherit from when defining employees, we're going to have a general group class. And this is very useful because a team will be a type of group. Team will inherit from group. But we're also going to later define a company, which is not a type of team, but is a type of group. So company will also inherit from group rather than from team. So a group has a set of members, and we can add and remove members as well as get the member IDs, get all the IDs of employees in our group. So that's a quite simple class. I'm not going to spend more time on that. This is actually a dictionary. I said it's a set of employees, but it's actually a dictionary. We can see that here. Also, actually, if you just say type brackets, that will be interpreted as a dictionary if it's empty, not a set. For a set, you would have to say something like set. This gets interpreted as a dictionary. So we have a dictionary of members where the values are the members and they are keyed by the ID of those members. Very simple class, not going to spend more time on this. The team inherits from group, so it can do all the thing group does, but it does it has some extra attributes and can do some extra things because it has some more methods. So when we define a team, that team has a name, an ID, and a description. Now, we've set here manager equals none. I probably would not do it this way. I would do it slightly differently. I would say something like manager. That might be something that we know in advance. So I'm going to put manager equals none here. So by default, the manager will be none unless we specify one. But if we specify one, then we can just set it right away. That's probably the way I would do this. Then, once we have set these attributes, we initialize a group. And remember, when we initialize a group, all that happens is we create this members dictionary, and it's empty. We could have put this at the beginning, along the lines of what we did for employee and manager. We put it at the end. It doesn't make a difference in this case, because all that's happening when we initialize a group is we create this empty dictionary. So that doesn't interact with anything else we've done so far in the object initialization. And appropriately, we can do things just like a group, we could add or remove members. For a team, we can add and remove the manager. Likewise, or slightly differently actually. We have some methods that take advantage of the structure of the objects that make up our team. So we have this check health method, for instance, which checks whether a team has no manager, checks whether the manager can manage all of the members of the team, and yeah, so given what we know about the composition of the team, it's composed of employees, and it has a manager, hopefully, we can check that kind of the conditions we would want to be true hold, which is that there is a manager and that manager is not over capacity. So that's what this method does. And I can see now actually why this was set to none before. It's because add manager not only sets the manager to a particular manager object, but also adds the manager as a member to the group. So that is important, that the manager count as a member of our team. We can calculate the total production of everyone on the team. That's just this sum of productions for every member of our team. And then we can describe the team as well. And then finally we have a company, which is another type of group, but different from team. So a company does not have a description or an ID or a manager. It just has a name and members. Just like the team, for production, we're going to sum up the productions of all the members. Notice for team, production is an attribute with an attribute of I. It's just a variable, because we expect I here to be an employee or a manager. Here we have brackets after production, which means we're making a function call. This implies that we expect the members of a company to be something with a production method. In particular, in this case, a team. What if we wanted to allow a company to contain employees which are not members of a team? That would be fairly simple. We would simply have to define a production method for individual employees that returns their production. Then we could call production. This gets a little bit complicated because now we've overloaded self.production. This is self.production, as is this. So we might say something like, I don't know, call this prod. And then down here, for team, we would just call the production method of the employees. But I'm not going to do any of that. I'm just illustrating that we could choose to do this somewhat differently if we wanted our company to have employees that are not assigned to a team. We then have some more methods. I'm not going to go into depth about them, but they check things like that employees are not assigned to more than one team, and that all the teams are healthy. So now that we've defined all of these interrelated classes to describe our company, let's actually make some objects and see how they are structured relative to another when we actually construct the company. So we can make some salaries and degrees. In this case, we'll just pretend like, our company is very simple. It only pays out a low salary, a mid salary, and a high salary. And all the degrees, or the degrees of all the employees are those listed here. We'll make some employees. Fred, Amy, Erica, Jerry, Sam, Danny, Carrie. And for the most part, their IDs are just incrementing by 1, but there are some gaps between 2 and 5, 5 and 7, etc. And then we'll also define our managers, and that's where actually those gaps in the IDs are. Arnold is employee ID 3, Sally is employee ID 4, Molly is employee ID 6, and they have some different capacities, 5, 10, and 10. We can initialize some teams, tech, sales, and executive. And we'll put some of the employees on the tech team and add a manager to the tech team. We'll put some employees on the sales team and add a manager to the sales team. And then the executive team at our company has just a single member, and that's its manager, Molly, who is probably like the CEO of the company, right? They're the only manager in the executive team, the only member of the executive team. So they're probably the highest in our hierarchy in the company. And then we can make our company object, and we add each team to our company. Now, what's pretty interesting is in our class definitions, we had all these inheritances and also all these places where we made some kind of assumption like, oh, the members of our team, we can iterate over those members and sum up their production, because we know the members of our team are going to have a production attribute because they're going to be employees. And because of that inheritance and because of the way those classes interact, using the attributes and methods of other classes that we expect to be stored in the attributes of classes like team, we can, from a very high level, from the company level, get a lot of information percolating up from the very low level objects like employees, degree, salary, etc. So when we describe our company, we can, for instance, say, okay, the company is healthy and has this total production. And then we can break out into more detail. The tech team has 4 members and produces this much money, and etc. for sales and executive. We also know that when we describe the company, we check its health, if there's any problems. So for example, if we decreased Arnold's capacity to 3 and described the company, why did this not work? Okay, so team 2 is clearly having problems. Check health. Problems. If not, self.single-assign. So we can see that team 2 is having a problem. We did team 2 here. Check health. False. Too many employees for manager. So at the company level, when we check health, we first check that all the employees are only assigned to one team. And if they're not, we append a problem to our list of problems. And then for every member, we check those are teams, we check the health of that team. And if the team is not healthy, again, we append that problem to the problems, and finally we return problems. I see. Here, if there are problems, we don't print out anything from describe. So here we could add else, print problems. Maybe not the most, maybe not the prettiest solution, but an easy one. Sales is not healthy because too many employees for manager. So maybe we'd say like for problem in problems, print problem. Perfect. So we can see that like changing things about these low level objects like manager has an impact on what we get reported back from the company when we use its methods to introspect its state. We can even drill down into the company and pull out those low-level objects like an employee carry by looking at the members of the company, those are teams, and then the members of that particular team. So this is a really nice kind of like hierarchical and like structured model for what our company looks like. However, recall that since these are Python objects, they're stored in memory, which means that this is a fine working model for our company, but as soon as we shut down our computer or close our Python session, all the data gets lost. And furthermore, it's very difficult to share this data with others because it's in the memory of our computer. So we would like instead to permanently store the data in a backend, namely a database, which will be persistent and can be accessed by any number of applications concurrently over the internet, perhaps. And so what I'm describing is essentially we would like to store our data in something like a SQL database while maintaining these nice kind of object type abstractions for interacting with the data in Python. And that'll bring us to object relation mapping, which we'll discuss in the next video.